Hello everyone, welcome back to the workshop. Today it's going to be another Bantam video, and we're going to be working on the sprocket assembly. There's a small spacer sleeve on the sprocket assembly that's completely worn out. We need to make another one, so it's going to be all about lathe work, and I know quite a few of you really enjoy the lathe work videos, so hopefully you'll get something out of this. Subscriptions are now at 240, so that is phenomenal. Thank you very much indeed to everyone that's subscribed. We're getting about 1,000 views per video, roughly. So if you're not subscribed and you like what we're doing, please consider hitting the button. And also, if you really like what we're doing, hit the little bell motif as well, and it'll pop up when you least expect us with a new video. So thank you very much indeed. It's really appreciated. And let's get on with the video. Okay, so here we are. Another day, another slight problem to overcome on our BSA Bantam engine rebuild. So we're looking at BSA service sheet 506 and the illustrations of the oil seal assembly on the gearbox main shaft output. And if you can imagine the shaft coming through here, with the splines on the end, and the sprocket sits here. So if you think of a more modern bike, a sort of small capacity Japanese bike or something along those lines, generally what you'd expect to see is a housing with a bearing inside it, and then on the outside an oil seal that you can sort of visibly see, and then your sprocket would be somewhere here. BSA did it differently. I'm not entirely sure if this is a hangover from the origins of the engine, which was DKW or DKW if you're watching in a German-speaking country. I'm not entirely sure, but this is how they did it. And the consistent parts are, if you think of the engine casing being here, imagine being able to see the main shaft bearing visible from the outside. You have a gasket, you have this steel keeper plate which basically sits over the bearing, sealed by this gasket. You then have another gasket here which seals this triangular shaped oil seal holder, an oil seal pressed into the inside of the oil seal holder. We have the steel sleeve which fits over the end of the shaft, sits in the oil seal and provides distance, clearance for our sprocket, which is here. That's where our sprocket goes, on the end there. And the purpose of that sleeve is to prevent our sprocket from chafing on our oil seal holder, and obviously to preload the whole assembly, so that the tension on the sprocket nut isn't trying to draw the main shaft out of the gearbox. So that's how it's all supposed to work. And the problem that we've got is that this steel sleeve, item F, isn't providing us with any clearance. It's flush with the oil seal holder. And we are using genuine BSA gaskets that I got out of an old BSA gasket set that I have, because when I originally assembled this I used aftermarket gaskets and they were too thick, and I had this problem, and I thought, it's the gaskets, they're too thick. I'll break into that genuine BSA gasket set I've got and see if the gaskets in there are any good, and they were, but I still have this reduced clearance. So examining this sleeve showed me that there's quite a bit of marking on the back of it, a bit of knife edging, and I think that it's quite worn. So we need to do something about that. So let's go over and have a look at the problem on our engine. So here is our problem in the metal, as it were. Here's our triangular shaped oil seal holder. I've already removed 2 of the screws, and here is our steel sleeve fitted over our spline shaft. And if I just run the screwdriver down the housing, down the oil seal housing, it only just catches the edge of the screwdriver. So hardly any clearance there at all. Certainly not enough. And there are some witness marks on the housing already. So I imagine that this problem has been going on for some time, and the previous owner had the same issue. But nevertheless, we'll take it apart and have a look in a little bit more detail. So just remove the final screw, withdraw the assembly. I'll be careful because there's a gasket behind here. There we go, you can see main shaft bearing. This here is the keeper plate that I was telling you about, and then we have the paper gasket which I've greased just there on the outside. Here is our oil seal inside the housing, and then inside our oil seal is our steel sleeve, and give that a bit of a wipe down. It's got a little bit of oil on it. I don't know how well that will show up, but it's quite well marked, so you can just see a little bit of a. It's difficult to get it to focus. There we go. Down here at the lower portion you can see it's a little bit stepped, so that indicates to me that there's been somewhere, and we need to replace this. Now I think they are available to buy, but we have a lathe in the workshop, and you know, there'd be no fun in just buying one and putting it in there. So I think we'll have a go at making one. So here's our steel sleeve that sadly is no longer going to do the job for us. It's undersized, it's suffering from some wear and tear, and needs to be replaced. So we could contact our British bike parts supplier, and if they had one in stock we could have it probably within a couple of days, but we have a workshop, and there's no challenge in that, is there? So we're going to have a go at making one. So enter our piece of material, which is a chunk of stainless steel. This is S130, which is a British standards designation. It's an aerospace stainless steel. Nickel chromium are the alloying elements, and it has a stabilizing element as well, which is niobium, and that makes it particularly resistant to intergranular corrosion. Makes it very good for welding. You find welded assemblies made from this, and also good for use in high temperature environments. So you would typically find it in P2 air takeoffs or air ducts on gas turbine engines, or sometimes in the exhaust systems. And yeah, it's a good material. It's not heat treatable, it's in its final state, but it's quite tough. Brindle 255, Rockwell A63, so more than adequate for what we need to do, and I'm pretty sure we'll get our steel sleeve out of that. So we'll go over to the lathe, get set up, take some measurements, and have a go at producing our new part. Well, we're set up in the lathe, and we are running in the 3-jaw chuck, basically because that's what was fitted to the machine. Hindsight, we may have been better off running with the 4-jaw chuck and clocking it in. This material runs off a little bit, there's a little bit of runoff, hence why I've got the fixed steady fitted to the machine. Prior to putting the tailstock center, drilling for the center, I used the steady just to give me a little bit of peace of mind, really. So it's not doing anything at the moment, it's out of the way. But this stuff cuts like silk, it's really nice. I've taken a facing cut and a couple of surfacing cuts just to see what the speeds and feeds are like. And as I say, with my favourite knife tool, which is this Seiko here that my brother sent me, it cuts really, really well. It's a bit too big for this machine. I've got it in a tool post extension, and you'd think on a machine this size the overhang would give chatter, but it really doesn't. It's a really good setup, so I'm pleased with it. Let's take some measurements. That's probably the next thing to do. And the OD that we're looking for is 28.6. So I've got the caliper dialed in at 28.6. Thereabouts, and just use that as a guide, just to see what needs to come off. 8.7. So we've got a bit to come off yet. And I think what we'll do is take a couple of cuts on camera so that you can see how it machines, and then I'll do the majority of the labour-intensive stuff off camera. And I think we'll probably go to final size or there or thereabouts, and then bore it out. There might be some value in leaving it a little bit large, boring it out, and then finishing off our OD. But to be honest with you, I'm not expecting this material to store up stresses really. I think it'll probably be good enough for what we're doing if we just go to final size and then bore it out. I want to do as little as possible without the tailstock, although I will put the steady in when we come to work without the tailstock, and obviously to part it off. But let's see how we get on. I'll stop rabbiting on. Hopefully the noise won't be too much for the camera. You're up there on the tailstock, so let's see how we get on. So we're running at 860. No, we're not. We're running at 630. Sorry. 0.25 is the feed rate, and we'll take a ½ mil per side. See how we get on. It's not breaking the chips quite as well as it was before. Might just have to push the feeder a little bit. Finish is still really good. So yeah, it's cutting really well. I might just push the feeds a little bit and see how we get on, but I'll bring you back when we're a little bit closer. Right, you're back with me. We're at ½ millimetre to go, and I've just had to change the tip because the surface finish went down the bog. So I've just changed the tip. As I say, we've only got ½ mil to go, and this could be a bust if the surface finish doesn't come back. But let's just see what happens. See where we end up. Well, that looks like it's cleaned up absolutely beautiful. So luck must be on our side. Thank goodness. I was dreading having to do it all again, but thankfully the tip didn't go on the last cut, which would have been disastrous. But let's see where we are numbers wise. .003. So do you know what? We're going to live with that. That's good enough for me. So that's us on final size here. I'm just going to let the whole thing cool down a bit, and then we'll have a look at shifting the steady up and boring out the centre prior to parting off. So that'll be our next sequence of operations. Well, this part's had time to cool down properly, and I've just checked it with a micrometer with the 25 to 50, and I have cut this a little bit under. It's only 1/100th under, but I would rather it was 100th over. I was a little bit concerned that the machine might be cutting a slight taper, but it appears not to be. When I set this machine up in here, I set the bed twist with shims, and I got the tailstock pretty much spot on, and yeah, it was the amount of taper that I was detecting was absolutely minute. So I don't think that's changed. I think it's just that I've not let it cool sufficiently when I've been measuring, and I've lost out a little bit on the expansion. So that's not on the machine. That is squarely on me. That's laid at my feet. This machine is really accurate. You can hit the numbers really well with this machine if you're very careful with the dials, and of course if you take into account the expansion of your parts. But I think 100th is going to be all right. I did try the oil seal, and you know, we're within range. It still feels nice. I would rather it was 100th over, as I say, but it's 100th under. But we'll go with it. I'm not going to scrap the part for that, so we will carry on and put a hole in it. Okay, we're getting reasonably close. I'm going to take a measurement. If I can get in there. Just going to use my little snap gauge. Like the feel of that. Let's try it again. Okay. We'll do best of 3. Just go a little bit further down the hole. Shouldn't be cutting taper, but you just never know, do you? Worth checking. Okay, consistent so far, 22.15. Let's do another one. rock, paper, scissors, you always do best of 3, don't you? So it's only fair. Okay. Yeah, spot on, 22.15. Oh, it's not going to focus, is it? You're just going to have to take my word for it. So we're shooting for 22.3, or actually just a little bit under 22.3. If I can get it 22.29, I'll be pleased. So yeah, just a little bit under. To use the technical term, a badger's nadger. So we'll do a little bit more boring and see where we get to. So I'm just going to take a cut. This one's, I don't know if you can see very well from there, we've got quite a lot of stick out on the boring bar, and that's because I'm using the steady and I'm really struggling to get in with the lathe carriage, so I've got quite a lot of stick out. But it's given us quite a bit of spring, so I'm just going to take another cut of this setting just to just take some of the spring out of it. Slowed the lathe down a bit now, running at 240 RPM. I think the amount of spring we're having is giving us a little bit of bell mouthing. You notice the chips changing. But hopefully we can work that out. And we won't be using the full length of the piece anyway, so hopefully we can keep that to a minimum. Right. Going to stop now and have another check, see how we're getting on. Well, this is hopefully our cut finale. We shall see. Okay, another measure. Well, we were shooting for 22.29, pretty much where we've ended up. So I'm pleased with that. That went quite well considering the flex that we had in the boring bar. Managed to work it out, and surface finish is incredibly good. This is nice material. So I'm very pleased to be taking the boring bar out now, because that was quite a tedious operation. So we'll tidy up the sharp edges and then we'll do some parting off, and hopefully with a bit of luck and a fair wind we will have our shiny new part. Let's snap the sharp edge off. And we'll do the same the bore, and then I'll get set up for part. Let's talk a little bit about how I set up to do parting on this lathe. And the big thing really is getting the tool square to the job, making sure that the stick out on the parting blade is at an absolute minimum to do the job that we want it to do without fouling on the tool post or anything like that. And also that we get the parting blade in the right position so that when we part off, we get the length that we need, the dimensions that we need. So the first thing that I do is set up the parting tool to 90 degrees. And I generally, if I've got something that's quite a decent flat surface on it, I just use the parting blade and I square it up to the end of the workpiece. And that generally, serves quite well. But with something like this, I use a square, and I set up the tool post. Excuse me, the tool post to the compound using a square, and that ensures that the whole plot is at 90 degrees. So now we need to find our start position, and I do this by putting the tool, the parting tool, right on the end of the workpiece like that, and bringing it back. And now we're going to go and have a look at my my measuring instrument that I've got on this lathe. I haven't got a DRO on this lathe, but I have got an analog travel dial, an ARO if you like. So we're going to have a look at that and see how that works. Right, so we're looking directly at our travel dial, or ARO, or whatever you want to call it, our means of measuring lathe carriage travel. And it's very accurate. It works off a vernier scale, as you can see. And so the last operation, we put the parting tool right on the end of the job. And we know that the parting tool is 3 millimeters wide. So we need to take 3 millimeters out of the equation, and that will give us our starting point. So if we just zero our travel dial, and let me get that absolutely spot on. There we go. So we're absolutely on zero now. And then we move our carriage by the 3 millimeters. I mean, you don't have to do it this way. You could just get your final dimension that you want, add the 3 millimeters and do it all in one go. But this, breaking it down like this, just gives you a little bit more eyes on the travel dial, and just shows you how this feature works. So let's move it 3 millimeters, and then we'll go back to the parting tool and have a look at it. And apologies if this seems a little bit noddy and sort of obvious, but I just thought it was worth showing. Okay, so we're spot on 3 millimeters there. So our parting tool should be in the start position. Right, so I've just snugged the tool up to the job, and you can see there, I think, that it's right on the edge. And if I just put the steel rule across, I'm hoping that my fingers won't get in the way and you'll be able to see what I'm doing. Yeah, the steel rule is absolutely flush with the ceramic insert of the parting tool and the end of our workpiece. So you can be absolutely reassured that you're in the start position, that your measuring device is accurate, and that any dimension that we dial in now will give us the length of the part that we need. So that's just a little quick sort of look at the measuring system on this lathe. It came on the lathe, I didn't buy it. It's quite an old piece of equipment. I think it was made in Sweden, but I can't remember the name of the manufacturer. But anyway, it came on this lathe. I'm guessing it's 1970s vintage, as is the machine. So yeah, that's the measuring device, and it works really well. Okay, zoomed in on the parting tool. Not entirely sure how much of that you're going to see. I've got the light kind of positioned. Hopefully you get a decent view. Just do a little bit of parting. It is complaining quite a bit. And we're listening for those telltale noises that indicate a dig-in is imminent. Right, so it parted off quite nicely. It's left a little bit of a rag. We'll take that off with a lathe tool, and then we'll just deburr it, and all will be well. There we go. And we'll give it a nice deburr, and then we'll try the part and see if it fits. So there is our part. And we just need to assemble it together and see if it solved our problem. That's our part installed now, and it went in very nice, fits quite well. Everything's nice and free. It felt like we had a good seal on the oil seal, on the outer diameter, and the inner diameter was nice. Didn't feel excessive, so we should be all right there. Quite how they don't leak down these splines, I don't know. Maybe they do, but we'll see. But we've certainly got a good snug fit on the shaft and on the oil seal. So we'll fit the sprocket and see what the clearance looks like. Right, that's the sprocket fitted. We haven't fitted the lock tab yet because we're going to take it off and just do a few final bits and pieces. But we have no interference with the housing, and we've only put about 1.5 mm on, so that shouldn't interfere with the chain line. We don't have the actual dimensions of the original part, but about 1.5 mm is perfect. So I think that's that job done.